If you're looking to get a better handle on your time, you've probably tried all the usual tricks. But what if the best advice didn't come from a productivity guru, but from, well, from computers? Let's dive into some surprisingly human lessons on how to get things done straight from the world of computer science.
Our story kicks off way back in the summer of 1997, and it doesn't take place here on Earth. No, our story starts on Mars. NASA's Pathfinder rover touches down. It's this absolutely massive achievement for humanity, and right away it starts beaming back those incredible, now iconic images of the red planet. The mission is a total triumph. But then, just a few days into the mission, silence. The data just stops. The rover has plenty of power, it's busy doing something, but it's failing at its single most important job, talking to us back on Earth. In a way, it was procrastinating. So what in the world, or I guess on Mars, was going on here? And really, what could a multi-million-dollar rover's technical problem possibly teach us about our own struggles with getting things done? Well, it turns out a whole lot. So, the NASA engineers, they put on their detective hats, and they eventually found the culprit. It wasn't a hardware problem. No, it was a bug in its software scheduler. That's the little part of its operating system that decides what tasks to work on and, crucially, when to switch to something else. And this should actually make us all feel a little better, right? Even super sophisticated computers can get totally overwhelmed. When their scheduling system breaks down, they just freeze up and fail to do the one thing that really matters. Does that sound at all familiar? This brings us to our first huge insight, what we'll call the prioritization trap. You see, all the time we spend organizing our work is time we are not spending doing it. Just think about your email inbox. You open it, you scan every single message trying to find the most important one. You deal with that one, and then you do the whole thing all over again. It feels productive, but it's a trap. Now, in computer science, there's a name for this problem. It's called a quadratic time algorithm. It sounds complicated, but the idea behind it is simple and honestly kind of devastating. As your to-do list gets bigger, the work it takes to perfectly prioritize it doesn't just go up a little bit, it explodes. And this slide, wow, it just lays it all out. If your inbox doubles in size, it doesn't take you twice as long to sort through it with that find the most important method. No, it takes 4 times the work. If it triples, you're looking at 9 times the work. You end up burning all your energy just trying to figure out what to do next. Okay, so this isn't just some abstract theory. This is a very real problem that actual programmers have had to solve, and their solution is just brilliantly counterintuitive. Get this. Back in 2003, the developers behind the Linux operating system, which runs a huge chunk of the internet, noticed their system was doing the exact same thing we do with our inboxes. It was meticulously ranking every single task in perfect order of importance, and because of that, it was spending way more time ranking than actually, working. So what they do, they threw out the perfect system. Instead of one long, perfectly sorted list, they created just a few priority buckets. Think high, medium, and low. Suddenly, the system was a lot less precise about the exact next thing it should do, but it more than made up for it by simply making way more progress. And that's the crucial takeaway here. Insisting on finding the absolute #1 most important task can actually lead to a total meltdown. Sometimes just grabbing an email at random and answering it is better. Giving up on that idea of perfection might just be the key to making progress. All right, so that's the prioritization trap. But there's another hidden productivity killer we need to talk about, the high cost of interruptions, or what we're going to call the interruption tax. Every single time you switch from one task to another, say from writing a report to checking a quick notification, you perform what computer scientists call a context switch. You literally have to unload the old task from your brain and load up the new one. And as this shows, every single one of those switches has a cost. It's never free. This creates this constant battle in our modern lives. On one hand, you've got productivity, getting real, serious work done, which means you have to minimize those costly context switches. But on the other hand, we're all expected to be responsive, to react instantly to every email, every ping, every notification. These two goals are fundamentally fighting against each other. So how in the world do you manage this? Well, once again, computer science has a really elegant solution for us. It's a technique called interrupt coalescing.
Instead of a computer stopping what it's doing for every tiny little event, like a key was pressed or the mouse moved, it groups all those little interruptions together and deals with them all at once, in a single batch.
And listen, this is not a small tweak. Back in 2013, putting this idea into practice led to a massive improvement in laptop battery life. And why? Because by batching all those interruptions, the computer could handle them all at once and then quickly go back to a low-power, resting state. It actually got to rest.
And the amazing thing is, we can do the exact same thing. Step 1, turn off all those non-essential notifications. Step 2, schedule specific times to check in, maybe once an hour. Then, when that time comes, process everything in one efficient batch. And this is the most important part. You then get to return to your own low-power state. That is deep, focused work. Ultimately, if we start treating our own attention with the same kind of respect that a computer treats its processing power, we can reclaim our focus. We can give ourselves back something that feels so incredibly rare and precious in our modern world, a real chance to rest. So, the idea I want to leave you with is this. We now know our attention isn't some infinite well we can draw from. It's a finite resource, and it gets taxed with every single interruption. So the real question is, knowing that, how are you going to choose to protect it?